So today we will cover solutions of our first ICPC training session. So the first task was to find out whether the string is palindrome. So what do we mean by palindrome? For example, this is the string. The first symbol is the same as the last symbol, and so on. So the second is the same as the one before the last. So what we need to do is we need to start a counter of all symbols that fail the equality restriction. So what we do, we go for loop. We start either from 1 or from 0, depending on which programming language you use. And then we go to the length of our string divided by 2. So if we have here string of length 3, we go to 3 divided by 2, which will be 1. But if we start from 0, then we need to subtract 1 as well. Next, we check if this symbol is equal to the symbol from the end. And if they are not equal, we increase the counter, and that's all. So we just count how many symbols that fail this comparison. We go only to the middle, because if we go over that, then we count every such uh, breaking point twice, and we don't need to do this twice. Let's go to the next problem. So the second problem is even easier than the first one. Here we are given a special type of square where all the numbers are sorted. So the smallest number is here. Then they increase to right and increase to bottom. Then we're asked to determine how many counterclockwise rotations we need to do in order to get from the given table to the original one. Just find the smallest number. So here it is 3. And we will look here at the options. So where it is located. It is located in top right position. So we just need one counterclockwise rotation. So instead of looking into the whole table, we just need to look into 4 corners and determine which number is the smallest. We can do that because in the task itself, we are promised that all numbers are different. Okay. So let's go to the next problem. Here we have another problem, which is very easy. So we can have anything as input, any string, and we need to compare the string to this strange information. And if these strings are the same, we output enough. Otherwise, we output OK. So we need to use string comparison properly. Well, the first thing, you can just compare one by one symbols if you want, and then check if the string has more symbols than it is. Just make sure that you take into account some symbols like that. Because when we read strings from input, sometimes some programming languages attach this to the string at the end because it was written in the file, so that's why they read it. So we need to disregard such symbols if they are, and then we just work with the string to compare. Okay. So I hope this one is easy. Okay, so let's go to the one not hard but complicated task. Okay, so this task asks you to find what is the smallest number of operations you need to make all the numbers in the array to be the same if the operations you are able to do either multiply by some number or divide by a factor. So, okay, let's take a look at some special cases, and that's how we will understand what's going on. So let's say we have this thing. So this is just an array, and we want to make this array of the same numbers. So there are several ways to do that. First way, oh, we can divide all 2's by 2 and all 3's by 3. So we will apply operation 6 times. Another way, we can keep 2's as they are, and we can divide 3's by 3. So this is 3 operations. And then multiply all 1's by 2. Also 6 operations. So it really doesn't matter how we count in this particular case. Okay. Let's take a look at another example. So I have 3 2's and 2 4's. So what I do? I will divide these 2 4's by 2, and I will get all of them to become 2 with 2 operations. So as you see, the number of operations really depends if the number we are working with is a factor or multiple of other numbers or not, or they are co-prime. So in order to solve this, well, we can do different things. So the first thing we should do is to count how many times we have each number. So we create a dictionary with a number equals to how many times this number occurs, so the frequency. Okay, so we have that. Now we can start working with the number with the largest frequency. Okay, so we select the first number with the highest frequency. So those numbers that are equal, those items that are equal to this number, they will not be changed in case we select the whole array to be equal to this number. So we only need to change the remaining numbers to that. So what we do is we look through all other numbers and we understand whether they are divisible by that number or a factor of this number. And after we did that, we can say, okay, those who are divisible or a factor of this number, they can be changed by one move. So we count how many numbers we have and we add one operation. For all other numbers, we will need to divide them by their own value and then multiply by this selected number. So we will have 2 operations. So we multiply 2 by the number of such numbers. And we add them together, and this will be the value for number 1. Okay. So after we do this for number 1, we can go to number 2, and we can even decide whether we even want to go to number 2. For example, if the total number of numbers is n, and the next number, number 2, has a frequency such that if I subtract from n this number, this will be more or equal than my value. Then it means even if all the remaining numbers that are not equal to number 2 are factors or multiples of number 2, I will have to do like at least one operation then. And counting the number of operations gives me that, oh, I will have to do more than I already have. So I will stop. But if it is not the case, I calculate the value 2, and then I see, oh, if value 2 is less than value 1, so I replace value 1 with value 2, and I continue the process. So that's how we do it. Uh, I didn't tell you how to analyze whether the number is multiple or factor, and because the division is very long operation, I mean in time, it takes so much time to divide two numbers. So you must do it carefully. There are ways how to overcome that. For example, with multiplication. So instead of division, you go through all possible multiplications, and that's how you go through all the numbers. Okay. So try to solve this task by yourself, and let's go to the next one. Okay. The next task is about two operations. Well, you have to remove the median and add the minimum positive number that's not present in the array. So this is the case we have. Let's consider that. We have numbers from 1 to n, and we need to select the median. Okay, there are two cases, depending on the length being odd or even number. Let's start with even number. So let's decide that we have from 1 to n. So in the middle, we'll have n and n plus 1. So the first operation will remove the median, which will remove n, and then we add the minimum number that is not in the array, which is n. After that, we have odd number of numbers, and the median will be just in the middle. So it will be n plus 1, which we are looking for. And we will cancel that, but still the smallest number is n. That is not present in the array. Okay, now we have again the situation of even number of numbers, and the middle one will be this one, because we divide by half, and it's even number divides perfectly, and it is n minus 1. And then we delete n plus 2, so we add n minus 1 again, and so on. So we will add all numbers till 1 also will be added twice. Okay, so this is the situation when we have even number of numbers starting with. If it is odd, then we delete this odd number, and then we delete the number to the left, and number to the left will appear twice. So the number in the middle, if we have odd number of numbers, will be appearing in the sum once. So that's the difference. So having that difference, we can just calculate the sum. So this is just a sum, arithmetic sequence, and it totals to n times n plus 1. Remember that n is not the n in the question. 2n is the n in the question. So we need to change that. Okay, y is equal to n divided by 2. Okay, so we will take division by 2. And if it is odd number, n is odd number, then we will add the number to the sum. So sum will be equal to y times y plus 1. And then we can add also this number and divide it by 2 if n remainder of division by 2 is equal to 1. So that's the final form of the formula. And that's what we need. So you just calculate that and you will get the answer to this question. Okay, let's go to the next topic. So here we have n integers stored in the memory, and we want to analyze that. So we have numbers and we need to switch places of their bits in order to get the largest possible number in the beginning, then the largest possible second number being the second, and so on. So we need to look here. This is 10 to the power of 9. In order to save such numbers, for example, in C++, you will have to use long, long, and not just long, long, but also unsigned long. So this is the data type. You will need to read these numbers. So what's next? After we read these numbers, we need to output them somehow. So we will create, this is 10 to the power of 9, and we know that 10 to the power of 3 is almost the same as 2 to the power of 10. So 10 to the power of 9 is almost the same as 2 to the power of 30. I'll just create a table of array. We will have this is array of 32 numbers. So this will be 31, 30, etc. 1, 0. So this is array. And what we will fill it with? We will fill it with how many numbers have here bit equal to 1. So I will calculate the amount of numbers that has bit equal to 1 here. For example, it will be 2, 3, 15, 4. Okay. So next, we need to output all the numbers. So we will output number that takes off by 1 bit from each of them. So we will take 1 from 31, 1 from 30, etc. 1 from 1, 1 from 0. And while we're doing that, we will decrease this number. So now it will be 1, now this will be 2, etc. This will be 14, this will be 3. So next number will be also something like that, because we will erase this, we will write 0 here. This will be 1, this will be 13, this will be 2. Next number will not have 31st bit as 1 because it's a 0. So it will be the next number and so on. So you just go in the loop for I from 1 to n, and you print n numbers using this array. And we go through array a lot, but it's only 32 numbers, which is not much. And we have 10 to the power 5, which is also not much. So it can be done in 1 second easily. Okay, and let's go to the next. The next task is continuous fractions, and we need to find those fractions. Okay, let's take a look at one thing. This is P1, and as you see here, this is P1. So Pn is actually 1 divided by 1 plus Pn minus 1. So you start with P1, which means you have A equals to 1, B equals to 2. This is the starting point. And then we need to find what is the next fraction. So you go through the loop, starting with this number, I equals 1, and then till it's equal to n. And what we do is we calculate the new values of A and B. So new A and new B. Let's find them. So 1 divided by 1 plus A over B will be B plus A and B on top. So new A will be B, new B will be A plus B. And you might wonder, well, we have here a restriction A and B are co-prime. So 1 and 2 are co-prime. If 1 and 2 are co-prime, then B plus A is also co-prime with B because A was co-prime with B. So adding to B something that was co-prime with B makes a new number that's also co-prime with B. So the new numbers are also co-prime and they will satisfy this again and again and again. So that's just the formula. And you replace A and B with these new values. So A will be equal to new A and B will be equal to new B. And you continue this loop and then you output the numbers. So we need to output just A, so we'll output A. So if we have any questions, you can ask in the group and so on. That's the end of our session.